Okay, so today we're tackling a technology you've probably heard about a million times, from finance to art and everywhere in between: blockchain. It gets thrown around a lot, often called revolutionary, but it's also famously complex. Our goal here is to just cut through all that noise. We're going to get to the core of what blockchain actually is, how it works, and why you should even care. So let's pull back the curtain and see what's really going on. You know, the comedian Stephen Colbert once joked that blockchain is gold for nerds. And honestly, he's not totally wrong. It definitely has this reputation for being a little dense. But that nerd gold is powering a huge digital transformation. So let's crack it open and demystify it together. So what is a blockchain really? At its heart, it's just a special kind of digital ledger or a database. Think of it like a notebook. But imagine that notebook is shared with thousands of people, it's super secure, and it's basically impossible to go back and secretly change something you wrote earlier. Let's break down how that's even possible. To really get what makes this ledger so different, we have to start with a basic question. Where does all this information actually live? See, a typical database, like the one your bank uses, lives on a central server. Everything flows through that one controlled point. But a blockchain is different. It's distributed. This means thousands of copies of that same ledger exist at the exact same time on a whole network of computers. There's no single master copy. Okay, so it's a shared notebook. Got it. But how do you add new stuff to it in a way that everyone can trust is legit? Well, that's where the block and the chain parts of the name come in. Imagine you're in a poker game and we need to record your hand. Each card you get is a new piece of data, a record. These records get bundled together into what's called a block. Then that block gets added to our ledger. But it's not just tacked on to the end. It's cryptographically linked to the block right before it, which forms a chain. And the real magic, the thing that makes this whole system so secure, is that final step, something called hashing. Hashing really is the secret sauce here. A hash is just a unique string of characters that gets generated from any piece of digital data. You can't go backwards. You can't figure out the original data just by looking at the hash. The best way to think of it is as a unique digital fingerprint for data. And here is the really clever part. The digital fingerprint of each new block is created using the data inside it, plus the fingerprint of the block that came right before it. So you get this secure interlocking chain. Now, if a hacker tried to go back and change even one tiny character in an old block, its fingerprint would change completely. That would instantly break the chain because it wouldn't match the next block, and that would set off a whole cascade of errors. This design is what makes the ledger's history practically impossible to change. So what's the big takeaway from all this tech stuff? Well, when you combine that distributed network with this secure interlocking chain, you get blockchain's most revolutionary feature: decentralization. In a traditional system, you have to trust a central authority, right, like a bank or a government, to manage the ledger and make sure everything's correct. With blockchain, the network itself does all the validating. Everyone has a copy of the chain, and the network as a whole has to agree on which transactions are valid. So trust isn't placed in an institution, it's built into the system with math and code. And that's what makes a public blockchain so ridiculously secure. A bad actor couldn't just change their own copy of the ledger. They would have to gain control of more than half of all the computers on the network. That's what people call a 51% attack. And then change all those copies at the exact same time. On a big network, the amount of power that would take is just astronomical, making it practically impossible. Okay, so we have this super secure, decentralized way of recording information. What's it actually good for? Because believe me, it's about a lot more than just cryptocurrency. First, it's important to know there isn't just one kind of blockchain. You've got public ones, like Bitcoin, that anyone can join. But then you have private or permissioned blockchains that companies are building. These are restricted, which is perfect for things like tracking an internal supply chain. And applications are just exploding. The Ethereum blockchain, for example, introduced smart contracts. That's basically self-executing code that can automate all sorts of things. In the physical world, companies are using blockchains to prove things are authentic, like tracking a diamond from the mine all the way to a person's finger, or creating a permanent tamper-proof record of US election results. It's all about creating a single source of truth that everyone can trust. But, and it's a big but, for all its potential, blockchain has a massive hurdle to clear before it can truly go mainstream. And that hurdle really comes down to one simple thing: speed. Take the Bitcoin network. It's the most famous blockchain in the world,
and it can only process about 4.6 transactions per second. I mean, think about that. That's for the entire global network.
Now compare that to Visa. The credit card network processes on average 1,700 transactions every second, and they say they can handle way more than that. This right here is the scalability problem in a nutshell. The very things that make blockchain special, its security and decentralization, also make it really slow. That slowness is a direct result of how these networks stay secure, and that security method creates an even bigger dilemma, one that's become the technology's most serious point of criticism. See, to add a new block to the chain, many early blockchains, like Bitcoins, use a system called proof of work. Essentially, computers on the network, which are called miners, all compete to solve a really complex math puzzle. The first one to solve it gets to validate the new block and gets a reward for their effort. This constant, competitive puzzle solving is what keeps the network secure. But it is incredibly inefficient, and that's on purpose. It requires a truly staggering amount of computational power, which means it uses a massive amount of electricity. Just how much are we talking about? Well, a study from Cambridge University estimated that the Bitcoin network alone consumes about 121 terawatt-hours of energy per year. To put that into perspective for you, that is the same amount of energy consumed by the entire country of Argentina. And this all leads us to the central question hanging over this technology today. Does its amazing promise of a secure, transparent, decentralized world outweigh its very real-world costs in speed and energy? The answer is still being written, as new and more efficient blockchains are being developed all the time. But this tension, this tug-of-war between revolutionary potential and practical limitations is exactly what makes blockchain one of the most fascinating